Looking at family 1, who's got an equation for family under A? Who's got one for me here? Olivia?
18 minus 7 equals 11.
18 minus 7 equals 11. Okay. Ivy?
I use X and Y. Same. 11 plus 7 equals 18.
Okay.
Good job.
That's an equation. Okay, others? Yeah, Sean?
11 equals 18 minus 7.
11. Well, we got that one right here. That same thing, only different, okay? What about...
7 minus negative 11 equals 18.
That's 7 plus 11. I
Just
got
trying to rewrite it, you know?
y minus 7 equals 18. That's one of mine.
Oh, I did y equals
Well, Meredith, I've been asking for. Okay,
I was confused because you guys were using variables.
that's fine, though. That means that they just didn't use variables.
I did y
minus
equals
7.
18 minus
I'm good
7.
at I just said that, Meredith!
I put y plus 7 equals 18.
It'd be 18 plus 7, right?
Mr. Mac, I put y plus 7.
It'd have to be 18 plus 7, right?
Y equals 18 minus 7. That makes sense.
Y equals 18 minus 7. So this one's wrong then?
Y equals 11 then.
So there's also infinite.
This one's plus then.
Every day I'm a baller. I love y equals 11.
Oh, that's right. I had a minus instead of a plus on that one. Okay. What about this? You guys want a weird one? What about this one?
I got it.
What about 2y plus 14 equals 36?
Oh, I thought you were talking about family.
It doesn't really represent the situation great, but it's still true. All right.
You know, it's true. What if y equals like 4?
There's something about it that means I know it's true. But, yeah, so these are all the same. They're all equations that represent the situation, all equivalent. They all pump out the same answers. So now that you've seen this, I want you all to try family B. So who's got some equations for family B for me? Vinny, you got one?
X plus 5 equals 1.
X plus 5 equals what?
Y.
Okay, yeah, I like that. So now we have two variables, right? Two unknowns. Cam, is your hand up?
Well, yeah, but it was like the same.
How about this? Can you tell me what X would be equal to?
X equals.
Cam? Talking to Cam?
Well, it depends what y is.
Infinite solution.
It can be a lot of things. That's the whole point. So we keep y as y.
Y is the middle. Would it be 5?
Not 5 times y. It would be y. 5 less than y. X would be 5 less than y. Troy, you got one?
M minus 5. M minus 5 equals y.
Yeah, I think that's kind of what we got there. We just use x and y instead. What did anybody do? So we got x like 5 equals y minus x.
I also have another
Yeah, I
one.
did y plus n minus y.
You did m and y.
We did y minus
That's
5
right.
equals y minus.
Here's one. What about this? What about this? 0 equals y minus x minus 5.
Oh, I put.
Ooh, that's kind of a funky one. One more real funky one. You ready for one that's got a lot of extra
I have
funk?
one that's really extra.
What about pi times x plus 5 pi equals pi y?
How many children is that exactly?
We got. It makes no sense, but it's equivalent.
Well, no.
I'm looking at chat with you in 3,
To the left.
2, 1. Who would like to tell me what they did to both sides? Rap
They moved the decimal left to
3 to the left.
to the left.
I believe it was 3 to the left.
So like,
Yes.
if I move this one left, I'd have 0.00. So you're onto something here. To the right. So essentially, if they move the decimal 2 to the right, what'd they do? Multiplied by 100. So what was done? Multiplied everything by 100. Okay. By 100. So what this does, it tells us next, what this does is it changes the price from dollars to cents. It makes sense. So,
We didn't know that because it looks like 5.66.
okay, but then you remember, I was like, if stuff doesn't look right, we need to look on the board because it didn't print perfect. So the price is expressed in cents instead of dollars. What I need you to do as a table or a pairing at your table is tell me if it changes our answer from $60 jeans. Check it. Try it out. So let's do it to it. To solve this, I'm going to combine like terms, get 90x plus 270 equals 5670. I'm going to subtract 270 from both sides. I get 90x equals 5400. divided by 90, and I get x equals $60 still. Multiplying everything by 100. Did it change my answer? No, those genes, they still 60. Equation B. It says this one tells us what was done. They subtracted 2.7 from both sides. Who can tell me what that means in context of our genes? Subtract 2.7 from both sides. What is happening in context there? Ari? They subtracted 2.7 from both sides to get this new equation. In context, what are they doing? I used to have plus 270 there, now I don't. So in the context of the genes, what's going on here?
They're getting rid of 270.
Not just a simple, what is the 270? Tax. So they're saying, this is what the price would be if there was no tax. I want you to see if it changes the price of the genes. Try it out. Let's hit up this price without tax. So if I combine like terms, I get 0.9x equals 54. Divided by 0.9. And dadgummit.
Look at that. It's still
$60 gene still.
JP, did I not?
All right, equation C.
Stop. Please stop.
What did they do to equation C to make that one happen? What'd they do, right?
They took away the coupon.
They didn't take it away, they applied it. They're saying 10% off is the same thing as 90%.
Price.
Okay,
Oh, okay.
so what was done? So really they took off the coupon is what you're saying, kind of.
Yeah, they just took it off the equation, I should say. It's still in
I like to call it the coup.
but it's gone.
So I want to see if those genes still come out as $60. That's what we're testing now. All right, friends, let's hit this. If I subtract 270 from both sides, I get 0.9x equals 54, which means that x still equals $60. So the solution to every one of these equations that is different is always 60. What does that tell us about all these equations? They're the same. Equivalent would be a word that we use in math. Here's the other thing it tells us. If in an equation, which means left side equals right side, if whatever we do to one side we do to the other side, what do we keep on making over and over? The same equation. The fancy word that we're going to use is equivalent equations. Do you guys remember last year you did these hanger diagrams? You can imagine them leaning or a balance. One. All right. First one. Can it be 0? Thumbs up for yes, thumbs down for no. We're getting some no's, yeah, because 8 does not equal 10. The second one. Thumbs up for 0 to work, thumbs down if it doesn't. Up. So we're saying 12 equals 12?
Yes.
I agree. The third one, can x be 0? Yes or no? Yes. Anything times 0 is what? 0. And the last one, can x be 0? Yes or no? Ooh, there's some confusion on this one.
I go with
Okay, let's substitute it in. Friends, guess what 6 divided by 0 is?
So it's no.
No solution. You can't divide by 0, friends. It's nothing. It's not a thing. So, that is not 0. Here's how you're going to attack this. You've got a partner. You and your partner are going to pick 1, 2, 3, 4, or 5 for column A only. And you need to prove that they are true and why. So you're not all going to do all of them. You pick one, your partner picks one, and you're going to come up with a reason how you can prove that the equations are equal to each other. I'd like to run through these real quick and show you how I'm going to prove without even solving them, Vinny. I'm going to do this. I'm going to say, if I distributed this 4, these two things would be the same thing. Okay, so those are the same. On this one, if I subtracted 2x from both sides, it would equal 3x equals 24. So those two things have to be the same. For this one, if I divide both sides by -3, it gives me 2x plus 9 equals -4. So these two equations must be the same. On this one, if I use the commutative property to switch my -x and my +3, it gives me this, which means these two are the same. And for this last one, if I combine my like terms of 3x and x to get 4x, these two are the same. So here's what you need to do. Same kind of idea. I want you to each person in your group pick one of them from B and use that same kind of method to prove why they are not the same. So checking out this right column, what does it look like this person tried to do to get from this equation to this equation? Who could summarize that for me? Elsa?
Just switch around the equals and the plus signs, which it would be 9x plus 5x equals 4. So
Yeah, it looks like they added 5x. If I wanted to get rid of this 5x, what would I have to do with it? Subtract. All right, who'd like to give a shot at this one? What does it look like they tried to do and what did they do wrong to make an equivalent equation? All right, Benny.
try to divide 18 by 9. Well, and they thought
They tried to divide by 2 going this way?
Yeah.
Okay, it works, except they never divided the negative 8 by 2, did they?
Exactly.
All right, so those can't be the same. Who'd like to give this one a shot? B3, Ivy?
Well, I just knew that we're both equal for x, so then I knew 6x minus 6 does not equal x minus 6.
Yeah, it looks like they took a factor of 6 out, a factor of 6 out, not a factor of 6 out. And we knew from our last lesson, they have to do it to everything to make it stay true. All right, this one here. Who'd like to give this one a shot? Why aren't these the same? Right?
I was gonna do the last one.
You could do this one. Look at, how would they get rid of this negative 11 over here?
Well, negative it's negative, not positive.
That's true. But like, see how there's an x minus 2 left here?
It's a multiple.
That means, yeah, it's a multiply negative 11. So how would you get rid of times negative 11?
Well, you would multiply it to the it'd be negative
I would-
11x.
I wouldn't. I wouldn't. How would you get rid of times negative 11? How do you undo multiplication? Division. It looks like they added 11. Addition would not undo that division, right? And the last one, Troy.
They subtracted 4. I can't focus.
No, subtracting 4 is cool.
Well, I think they just added.
Oh, I did this one.
Look at it again. Subtracting 4 is fine. That works.
They
What-
added 4.
No, they subtract 4 minus 4 minus 4. Troy, stay with me.
I had 4.
Stay with me, Troy.
Here.
Subtracting 4 is cool. That works. Minus 4 minus 4. So what's wrong?
Oh, you're right. They just changed the negative 5.
This was a negative 5. Now it's positive. Just so you know, this is one of the 2 most common mistakes you all will make solving equations. You will also make this mistake. You'll also make this mistake. Some of you will also add 4 there.
5 is the negative one. Not the
Well, you'll do it because you see this negative.
positive.
It's wrong, Troy, but I'm saying some of you will do it. The only way to get rid of a positive 4 in that case is to subtract 4. Let's follow Noah's work here. Noah combined like terms here to get 1x. That's solid. And then Noah subtracted x from both sides to get it 6 equals 1. That works too. Where I want you to focus is this row right here.
Yeah, that's what I said.
That's what I was
Okay, Zeph, what are you noticing at that row?
What I noticed there is, so there's x plus 1, x plus 6.
Yeah.
And so like in the next row, they just ignore the x's.
But even not even think, they didn't ignore them, they subtracted them. Because if you do it to one side, you can do it to the other. It's still true, right? So, but looking at that row, x plus 6, x plus 1, what does plus 6 mean in terms of a number line?
What it means is they're adding 6.
6 to the right, right? And x is the same both places.
Yeah.
So what number can we move to the right 6 and 1 and right once and have the same number?
Like you have to do 6.
Well, okay, let's try it out. 6 plus 6 is 12. 6 plus 1 is 7.
Yeah.
So that don't work.
So you have to move 6 over like.
But I'm saying, it's saying for whatever value of x is, I'd have to move it 1 right here and 6 right here and have it be the same thing. What number works for that?
He's right.
What number works for that? And what number can you add 6 to it and add 1 to it and have the same answer?
Add 6
0.
to it and add
No,
one to it.
Well, let's try. That's a good guess. Ari says 0. 0 plus 6 is 6. 0 plus 1 is 1.
Multiplication.
What number works? We just tried 0. 0 plus 6 is 6. 0 plus 1 is 1. What was that, Ivy?
No number.
Yeah, here's the answer.
No solution.
No solution. There is no number that works. What that means is from the start, left side the left side does not equal the right side. There is no value of x that will make this equation
No
true.
no.
So looking quickly at number 2, we got 2 equals 3. What might you think?
I think that's probably no solution as well.
I think that's a conclusion that this would lead you to. However, I would like us all to look at this row right here. Is there a value of x we could consider that would make that true?
Yes.
What value?
1.
0.
Well, anything times 0 is?
0.
0.
So in this case,
Oh,
x equals 0. Yeah, you can. 0 is a number. What's the difference between these two things? Like looking at those two places I circled, what's the difference?
It's adding, it's
One's adding, one's multiplying, right? The identity property of 0 would say.
you can't add by 0.
Now I'm going to show you something in the algebra that will never make you have to even think this hard, okay? This is how I would solve this equation myself. I'd solve it a little different. If I was going to solve this equation, this is what I would do. I would go right here to the 10 plus 2x minus 1 equals 3x plus 9. I would combine like terms. 2x plus 9 equals 3x plus 9. Here's my move next. I know my goal is x equals number, right? So what I always do next every time is I get my variable on the same side. So 9 equals x plus 9. And when I do that, look at what it makes my x equal. 0. So if you do that method of getting your variable on the same side as soon as you can, it'll pump out the 0 for you. If you do it like Noah did, you need to consider this step right here. You can't just use your answer. Because 2 doesn't equal 3, that's not true. But x can be 0 right here and make it true. Again, if from right here you get your variable on the same side and eliminate one of them, it'll pump out the 0 for you. This one up here, it doesn't matter when you do it. You always get number equals number that isn't the same if it is a no solution. So it doesn't work. Let's summarize today.
We need to get out of summary pocket.
Nope. The big idea is, as long as we do it to one side and we do it to the other, same equation. And we can use that to get rid of stuff to isolate a variable. That's called solving equations. We've done it before. The other thing is, sometimes we have answers of no solution, sometimes we have answers of 0. We need to see if it's add, subtract, or multiply to decide which one, unless we isolate the variable earlier in our work. Have you guys noticed I always get that variable over early in my steps? Because I do that because if the goal is x equals number, I can't have x equals x. All right. Let me grab that homework for you and we'll get after it.